supplying you with pens, and you are ungrateful enough to say those aren't good enough to be the ones you want.
Does he need a third arm? No, we're not finishing his third arm.
So what do you think of that?
I think I'm just going to cut I'm going to cut this out. Well, first I'm going to square it and then cut it out, and maybe I'll frame that.
Why do you think you're so funny?
Rip off all my skin. Get the bugs and copper.
Whom are you talking to?
Me? Who isn't he talking to? Brandy?
Anyone else wants it? No, it's okay.
That's okay. I get it. I get it.
I do that all.
That's for everybody.
Okay, ladies and gentlemen, today is our last day of reviewing naming compounds. We have covered binary ionic, we have covered ternary ionic, we have covered binary acids, we have covered ternary acids. Our last kind of compound to cover, ladies and gentlemen, is covalent compounds. Covalent compounds are the least used in this class, but they are the easiest to do. Why are they easy? Because the name literally tells you everything that you need to know. There are no charges. There is no crisscross method. It is figuring out what two elements involved and how many of them are involved by the prefixes that you are given. What? Well, that's a great explanation of absolutely nothing except 4. It's like the tetra, whatever, tetra, whatever, tetra. That may be 16 because I think you use tetra 4 times, which is pretty consistent because then you use 4 times. Good, squared. All right, excellent, wonderful. All right, ladies and gentlemen, so here we go. So we've got the prefixes, mono, di, tri, tetra, penta. Those are the prefixes that we will use. As someone asked me earlier today, will I give those to you? Yes, I will always give those to you. I do not expect you to memorize them. Also, ladies and gentlemen, I will give you Roman numerals if you ever need Roman numerals. Now, please remember, these will be names that you are going to write formulas for. So you will already be given the prefix. You will already be given the Roman numeral. I will just have to tell you what it means if you do not remember, ladies and gentlemen. Hopefully, you will become familiar with it. So again, no charges. We are sharing electrons in a covalent compound. We are not gaining or losing them. Covalent compound, though, has to be between 2 nonmetals. I will not give you a covalent compound that has 3 elements in it. Okay? Only 2. No charges, and they do not have to be reduced. So when you're done writing it, if it can be reduced, don't. It does not get reduced. And it is written based on prefixes. So, carbon monoxide, ladies and gentlemen. What are the 2 elements in carbon monoxide? What? Carbon and oxygen. That would be the 2 of them. Marcus, was that the same 2 that you had?
That was the same.
Good, because that would be correct. Excellent. Awesome. Carbon and oxygen. Now, there is no prefix in front of carbon here. What does that mean? It means it's mono. Now, they do that for a simple reason, ladies and gentlemen. Many, lots of covalent compounds begin with only 1 of the first element. And if they put mono in front of all of those, when they then listed them alphabetically, it would be a nightmare. Because you'd be having a list of mono compounds that would be huge, and you would have to find monocarbon, so they don't put mono first. They will put mono second. So there will always be at least 1 prefix in these compounds. Okay? Always at least 1. So since there is no prefix there, ladies and gentlemen, that means that there is 1 carbon, and the mono by the oxygen, monooxide, means there is 1 oxygen. That's it. That's your compound, ladies and gentlemen. You are completely done. Questions? Clear as mud? Excellent. Wonderful. Do these then. There you go. 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 Timer's running. 5 minutes. We got stuff to do afterwards. Let's go. Oh, Dallas, did you have a pass or anything or no? Okay, thank you. Stop being late to my class.
Sorry.
No, you're not. Otherwise, you wouldn't have done it. Ow.
How are you doing?
Okay. Are you ready? What? Okay. So what are the 2 elements involved? Okay, so write down sulfur and fluoride. Oh, the symbols. We're writing formulas. Okay. Now that tells you how many S's. Okay, so put a 2 after the S.
Okay.
Then how many F's? Good. There you go. That's your compound.
Thank you.
You're welcome. Yours?
Do you mind if I turn off the buzzer thing before it starts buzzing all class?
Oh, so it was not gonna buzz when it was sitting there all class.
Oh, God knows.
I don't think God has anything to do with this.
Maybe. I thought he planned everything. He's gonna plan my phone to go off whenever you touch it. He told
Wow,
me.
that takes all responsibility for you completely away, if that's your belief, huh? Okay.
God's plan.
Evan, disulfur pentafluoride. Give me the formula for disulfur pentafluoride. S2F5. Perfect. All right. Nitrogen dioxide, Daniela. NO2. Carbon tetrachloride, Sasha. CCl4. Trisulfur octahydride, Abby. Hexacarbon decahydride. Go ahead, Jera. You sure about that? Thank you. C6H10. Yep. Okay. Triphosphorus heptaiodide, Rome.
P3L6.
Not L, it's an I.
I6.
I6. Thank you. I6. Good. Any questions, ladies and gentlemen? Questions, ladies and gentlemen? Ooh, yes. Sorry. Sorry, yes. Heptahexa. Yep. Sorry. I7. Good catch. Thank you. Okay. Questions? Wonderful, wonderful, wonderful. So yesterday, ladies and gentlemen, we left off, we were talking about doing metric or conversions with moles. Now, the key to doing conversions with moles, ladies and gentlemen, is the fact that we have two things that are equal to each other. And what we started out with was a mass to mole relationship. In other words, if you're given mass, you can get it into moles. If you're given moles, you can get it into mass. The thing that we use to get from moles to mass or mass to moles, ladies and gentlemen, is we use formula mass. Formula mass is the mass of the formula of the compound. So when you write the formula of the compound, ladies and gentlemen, you can calculate its formula mass. Okay? Now, one thing that I would like to point out to you real quick here, ladies and gentlemen, is this. If you have a formula such as magnesium, ooh, I don't like that. Such as magnesium hydroxide, you need to be able to balance off the charges, +2, -1. That is why this 2 ends up here, and that is why nothing is by the Mg here. This 2 comes over here to balance off the +2 of the Mg with 2 -1s of the OH. Are there any questions on that part of it? Okay, so then when we're finding a formula mass, we need to figure out how many of these things are in the formula. 1 Mg, 2 oxygens, 2 hydrogens. Once we know that, in place of the symbol, we put the mass. 1 times 24.31 plus 2 times 16.0 plus 2 times 1.01. These numbers here all came off of the periodic table, ladies and gentlemen. So again, depending on if you use an online periodic table, if you use this one, if you use the one above your heads there, you might get slightly different numbers. Slightly, which is okay. When we're done, ladies and gentlemen, this is 24.31 plus 32.0 plus 2.02, which means we end up with 58.33 grams of MgOH equal to 1 mole of MgOH2, magnesium hydroxide. Because these are equal to each other, ladies and gentlemen, I can make them into a conversion factor. I can put one of them on the top and I can put one of them on the bottom. If I want to get out of moles and into grams, moles is going to have to go on the bottom. Why? It's the only way they'll cancel out. If I want to get out of grams and into moles, I'm going to have to put the grams on the bottom because it is the only way they will cancel out. So the problem is going to set up how I use this fact. But I get this fact from once I know the formula. The formula mass is always equal to 1 mole of a substance. So the formula mass for antimony is 1 mole of antimony is 121.76 grams of antimony. The problem begins with 6.89 moles. So the way I'm going to use this to get out of moles, which I'm in and into mass, is I'm going to have to put moles on the bottom here. They will now cancel out. So whatever unit you are in, the unit has to be on the bottom here to cancel. This one goes on top. Now with all of these conversions, ladies and gentlemen, all of them, you will always have a 1 somewhere in there. Now we do not need to multiply by 1. We do not need to divide by 1 because it doesn't change the value. So what you will hear me say is, do we multiply or divide by the number that is not a 1? Well, when it is on top, we multiply by it. If it were on the bottom, we would divide by it. So we're going to take this times the 121.76, and we get 839.9. Now, I stopped there. I didn't write down all the numbers out of my calculator. Why? Because I knew I only needed 3 sig figs. And this number is far enough to tell me that I need to take this 8 and round it up to a 9, and I am done. Questions? Okay, problem 2 that we showed you yesterday was this. A sample of potassium chloride has a mass of 223 grams. How many moles of potassium chloride are present. So potassium chloride is going to give us the formula we need, KCl. We're going to then find the formula mass by taking the mass of potassium plus the mass of chlorine, which gives us 74.55. 1 potassium, 1 chlorine, add them together. 1 mole of potassium chloride equals 74.55 grams. So our problem now begins with 2.223 grams. So to get out of grams, which we're in, and into moles, which is what we're trying to find, the grams now has to go on the bottom. Grams and grams will cancel. We will be left in the unit of moles. 2.99128 is what I get out of my calculator. I stop after the 9, or I'm going to round in that spot. Since the number after it is a 1, I leave it as 2.99. Any questions, ladies and gentlemen? Now, this same concept can apply if we are doing a problem where we want to convert from liters into moles. The only thing we do different here is for liters to moles, there is a different relationship. What? 22.4. Correct. Now I'm not worried about formula mass. Why? Because I'm not in grams. But I do need to know how the mole relates to the volume of a gas. And 1 mole of any gas is 22.4 liters of space. Any gas at all at STP. So this conversion is actually easier than the last one because we don't have to calculate this number. We know this is what the number is. But we are going to use it the same way we did the last one. Because these two things are equal, I'm going to take what I'm given, my liters, and I'm going to take it times a conversion factor. In that conversion factor, I'm going to use this and this. Once again, I put liters on the bottom. Why? Only way to cancel out here. The units cancel out. But now it's always going to be 22.4 for this volume. Because I don't care what the gas is, its volume is always 22.4 liters if there is 1 mole of it. So we have the 22.4 liters on the bottom. Since this is smaller than 22.4, it means we have less than 1 mole here. Our number is going to come out to be a decimal. That is absolutely fine. This is the number that I get out of the calculator. Again, 3 sig figs in this number. So I stop this at the 3rd sig fig, the 0. The number after it is a 3, so I'm going to leave it. Questions? Okay. A sample of carbon dioxide gas occupies 3.79 moles at STP. How many liters of space would this gas occupy? Again, the relationship we need is the same as the last one. The only thing that I am changing here is what the name of the gas is. Now, I will tell you this on your quiz. Even though I don't need to know what this is to use this conversion factor, I give you a point for writing the correct formula for the substance that we are talking about. So you get a point for writing CO2. We now start with 3.79 moles of carbon dioxide. We are going to take this fact here and make the conversion factor out of it. But now, because we're in moles, what has to go on the bottom? Moles. And the 22.4 goes on the top. So that when we are done, we will end up in liters. Okay? So again, moles and moles cancel. Take 3.79 times 22.4. Get 84.896 or something similar to that in your calculator. When we round this, because we're rounding to 3 sig figs again, the 8, because of the 9 next to it, becomes 0.9. Questions? Now, the only way I could make this particular problem any more difficult would be to make you put your unit into milliliters. What's the relationship between milliliters and liters? Good. I don't care if you show me that, or I don't care if you slide your decimal 3 places. I don't care how you do it, but you got to get me to the right answer. And that you should have down from earlier in the year. Questions? Good. Open up the mass versus mole mass versus mole lab in your notebooks, ladies and gentlemen. When you get there, it should look like this. Open it up. This is what you're going to be doing in a couple of minutes. So today we're going to study the difference between the use of the mole and the use of mass when measuring a substance. That is what we are going to be doing. So, the lab procedure, ladies and gentlemen. Make 3 qualitative observations of each sample material. Excuse me. The 6 stations in the back, each one is set up with a different material, ladies and gentlemen. Right over here, there are paper clips. At the station next to it, there are marbles. At the station next to it, there are nuts. At the station in the back corner there are thumbtacks, there are washers, and there are nails. At each station, you will find a sealed bag which you will leave sealed the entire time. Do not do anything with this bag other than find its mass later on in the lab. Don't open it up, don't add any, don't take any out. You will find a container filled with the sample at your station. This is what you can use to make observations of. Qualitative means what?
No numbers.
No numbers. What you see, what you feel, what you hear, what you smell, what you taste, don't lick them. Do not taste these. Okay? And if they are talking to you, please let me know so I can get you the help you need. Yeah, I'm talking to you, Declan. Okay? We'll get you the help you need. You can smell them, you can feel them, and you can write down what you see. Okay? You have to give me at least 3 observations. There are 4 places there. Why? Sometimes people accidentally repeat an observation. So their observation will be it's shiny, it is smooth, and it is shiny. Or better, it is shiny, it is smooth, and it has luster. Shiny and luster are the same things, ladies and gentlemen. You're not getting credit for 3 observations if 2 of them are the same. So you will take and you will make your observations. After you have made your observations, ladies and gentlemen, you will count out 50 of these. 50 of them out of the container, and you will find their mass on the balance. There are weighing bolts here to help you. But I want just the mass of those 50 paper clips, not the mass of the 50 paper clips in a weighing bolt. So my suggestion would be to count out 50, have them sitting on the side. Now that you're ready, put the weighing bolt on your balance, zero it, wait till it's reading 0.000. Take this out, put the 50 in, put it right back on, find the mass. That will then get recorded in a table a little bit further down. If you will slide down in your lab a little bit, you will see a table where it has the average masses of them. So you're going to write the mass there, and you're going to do 50 in your sample. Now, you then need to do one more thing at the station. That one last thing that you need to do, ladies and gentlemen, and by the way, when you take this off, re-zero it, otherwise it's going to be minus whatever that mass was. And now, ladies and gentlemen, you need to find the mass of this bag of the pieces of paper clips. Now, little piece of advice from doing this lab for a few days. There is air inside of there. Try to get as much of it out as you can, but don't worry about it too much. But when you put this on your balance, you need to try to make it so that they are not moving around inside of there. Because if they are, if they're moving around a little bit when you set it on here because they're not packed down, it will change your number on here constantly. You want to put it on here. You need to make sure that the plastic bag is not touching any sides. You need to make sure that the plastic bag is not like this laying on the bottom. You want it all on the pan of the balance so that when you put it on there and you close the door, it stops moving. Now, I've seen people today who are like, Mr. Brand, it won't stay steady. I wonder why when you're banging on the table right next to it. Okay? Once you have that mass, ladies and gentlemen, once you have your observations and once you have the mass of the 50, you're done at that station, you can move on to another. You need to get all 6 stations done today. All 6. Now, if you're waiting for somebody at the station where there are the washers, but there are 2 groups there, go over, take 1 washer off of there, bring it to the middle here, make your observations of it. So that when you do get a spot at that station, all you need to do is count out your 50, find their mass, find the mass of the bag of them, and then you're done. Okay? Every station has enough stuff there for 2 groups at each station. By the way, do not assume that the weighing boat on one side is the same mass as the weighing boat on the other. So they zeroed it on their side. You're going to put your weighing boat on there and it's going to be zeroed out. No, it's not. It's not. Okay? So, here's where you put your observations. Here's where you put your masses. You're stuck waiting because there's a group that won't get out of the way at a station. Start doing your calculation. Take the mass of 50, divided by 50, get the average mass of 1 of the paper clips, 1 of the marbles, 1 of the nuts, 1 of the thumbtacks. Because you are going to need it in this table here. By the way, large bag of the, or mass of large bag of sample, that is the bag that is sitting there. Do not open it. Do not take anything out of it. Do not add anything into it. Put it on the balance and find its mass. Here's the mass of the bag that it is in for you so that you can find the mass of just the sample by subtracting these 2 like it tells you to do down here. The average mass of 1 piece. These are the numbers that you calculated here. These 6 values that you calculated here go here. And then you're going to find the number of pieces that was in that bag. And you're going to do it by taking the mass of the sample alone, the pieces in the bag, divided by the mass of 1 of them. And that will tell you how many are in there. So this should work out to be what kind of number? A whole number. Probably not going to happen. Should be close, but probably not going to happen. Yes. This is the one place where I want you to round. Okay? Everything else should be 3 places beyond the decimal because that's how we found the mass here. That's how we found the mass here. And when you did this one, you should be at least 3 places beyond the decimal as well. Okay? Questions? Oh, there are 5 of them at the end that you have to do after this. So, everything is out back there for you. Everything is ready to go. 3, 6, 9, 12, 13, 18. Good. 9 groups of 2. Go to work. Go to work. Go to work. Go to work. Find a partner. 9 groups of 2. Let's go. Let's go. Let's go. Jara, take your phone and put it in the box for me, please. Do you know who your partner is?
Yep. Abigail Edgar.
What? You got a fat phone? See, I got it big enough for fat phone. Evan. A what? Right there, sir. Unplug it from that cord. Grab the cord, grab the brick, go to work. There you go, sir.
Is there already 50 in here, or do I?
What?
Is there already 50 marbled in here?
No, there are not. And the marbles is the one station, ladies and gentlemen, where we cannot have two groups because there aren't enough marbles there. Okay, Marcus, who's your partner? Find one. Don't even ask. Evan, who's your partner? Find one. Don't even ask. Abby, I think your partner is Declan. Okay, that puts Marcus and Evan together as a group. Go, 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 go. If it kills you, I won't ever make you do it again until the next lap. But that is
I'll hold them.
yes. Now keep that number divided by 15. That'll be
Oh. Yeah. I'm holding 50 nuts in my. I got 5.
That's for on my No. They don't eat it, they just need the cans. No. It's just easier. Only our penalty lost down. Right, older it is. Yeah. Guess you'd have to ask them to find out. Yes. This is something. Otherwise, I could be explaining it to you, and then you come back and you don't need to. It's all selected, and then you do it over again, and it'll be amazing. Here's the thing. The whole lab on it, as long as you get these numbers, as long as you get these numbers, your observation, then I can explain it. I wouldn't just maybe there's going to be if it kills you counting to 50. If you get to the point where you get in a station, you can then work out your calculations later. I'm going to make a suggestion to you. Get everything collected. You can always do the math afterwards. Or if you're waiting to get to the station, I can go over the math with you at that point. But if it's sitting to the station, you may want to just let your data go on to the next one, and then I can show you what to do afterwards. Right? Always have. So you can write this whole number down, 174. Well, for that one, whatever. That's nice to do. If you can form, oh, I'm not very interested. So I'm going to speak in this measurement. And so I would go and reach. Sorry, you were. Sorry. Should have been zero before you put that on. Okay, how did you get off the table? Not even close. Oh, my mistake. Sorry. I have a hammer in the drawer.
Some of the large people for the same. Yes, the bag. Okay, well, oh, so it's I'm keeping. I'm gonna care. Yeah, we got everything. We're all good. Yeah. Sorry. I don't. I love you. That's all right. necessarily, because you might not be at the 200.
Well, actually, one of my
Oh my God.
my entire family when I saw her. And I came out and like they were really mean to me. And my grandpa when he saw me, he's like, I like your
Because that's the
I actually contacted both of my grandpas.
there's not 0.65
And my mom when she was younger.
What was the number I should call you? So 0.5.
No, I'm really embarrassed. Like, right?
We're not getting anything done.
Yeah.
The last number at the very bottom, because you're trying to figure out how many are in the bag. And you have 0.83 of them marked. Well, the last number, because we're saying that it's the number of pieces in there, cannot have a part called. I did. Wait. Wow.
Are you going to mark this up for me? If you do the math.
Where's the number going? Yes, it should be. What, you gotta give me a little more
Wait.
information where we're talking about.
Just the list, right?
Is the average use of one sample?
That is.
That's
So this, sample 170.470 minus the 2.219 because that sample was in the bag, so now we have to subtract the mass of the bag. What?
Is that massive bag?
Why are you doing
Wait, what rounds?
Yeah, which is they call it butter, they call it yes. I know, but it's so. Whoa, my 20 is an average.
Oh yeah, that's what it was.
0.96.
That's it.
Yeah. That's mass of 50. You need to divide that by 50 to get the average. Oh my gosh. 50 grand paperclip.
Happy paper just grab it. It's those giant paper clips. Some heavy nails. We have 45 gram nails. Oh my god. We have 45 gram nails. No, you do not. You did, because that is not divided by 50.
I know, I see it.
Okay. Well, first of all, what's the legal one?
I'm still going to use them.
Okay, please listen. You need to have all of your calculations done when you come in here tomorrow. So the mass that you got here, divide by 50 to get an average mass. Anytime you take an average, it's an average for one of those objects. One, that's what an average represents. That's why you divide by the number of them that are there. These numbers here, when you have divided by 50, go into your table down here, ladies and gentlemen, where it says the average mass of one piece of sample. So the numbers that are in the table up above go into this spot here. The mass of the sample alone is equal to the mass of the large bag of sample minus the mass of the bag. The number of pieces in the sample is equal to the mass of the sample alone divided by the average mass of one piece of sample. This number down here has to be a whole number. There was not a 0.62 of a paperclip. There was not a 0.385 of a marble. So you have to round those to whole numbers. Then, ladies and gentlemen, you need to answer the questions. Now, if you have all of this done, you will be able to answer the first two questions. If you do not, you can't answer these first two questions until you get that table completed. You may be able to answer the third one, the fourth one, and the fifth one. By the way, name 3 ways we measure things out that we buy in our everyday lives. I do not want you to tell me a unit. I want you to tell me what the unit measures. So, for example, if we bought something by the amount of time, I want time. Not seconds, not minutes. What does the unit measure or tell you? We buy things in a lot of ways, ladies and gentlemen. There are many right answers to that question. Many. Somebody gave me one today I hadn't even thought about when I wrote the question, but it worked.
What was it?
They said not to tell you, Nadia. Because Cynthia doesn't want you to know.
Can you tell me?
No.
Oh.
Okay? And then you have to answer the 2 questions afterwards, ladies and gentlemen. But you need to have all this done, the calculations, when you come in tomorrow, so that if you have questions about the questions, I can answer those questions, and you won't have any more questions. Questions? Good. Plus, we still got to show you how to do some more conversions tomorrow. And give you some time to work on it. Good news though, you guys are ahead of my second hour.
Oh,
Because you guys are my favorite fourth period class this trimester.
wow.
I know why you're ahead because Cindy talks so much.
Well. Oh, Abby.
She told me not to say anything. But she did say that she likes her replacement for you better in second hour than you last trimester.
Who is it?
Ask her, not me.
That has 5 in there. Oh, wait, you know, never mind, that's crazy. I just made up a whole store just to lie to you, Abby. It's because I live in like 5 universes at once. All of them are separately different. So you need to get 2 Papa Pickles, okay? What? I thought.
Goodbye, ladies and gentlemen. Go away. Have a good day. Get out.
Do you want the salt?
Door is that way. Use it. Go. Go.
Wait,
Go.
sister, sour
Go.
sister.
Be here
So
on
there's
time
sour
tomorrow. I
sister,
did change it.
There's
I did change it. Sorry.
big Papa Pickle.
Be
there's
here on
Warhead
time
or
tomorrow.
Warhead or whatever. What was the hot?
You tell her.
Hot Mama pickle? I don't want the Hot Mama pickle. Yes. So are they as big big Papa pickle? They're as big as that. Oh, okay. Well, you better come back with a big Papa pickle in your hands.
Declan,
What?
are you forgetting something?
Do I really need my phone? I'm just gonna disappear one day, Mr. Brain. I'll make sure I leave a note with your name in it.